All right, question 5 is another one of those that is a little bit weird because you're going to be including numbers that don't necessarily get involved in the math at every particular step of the way, but let's go ahead and set it up and see where things go. So what we are doing here is we are taking apparently another one of those containers, and in that container we are putting ammonium hydrogen sulfide, that's a solid, and apparently it's going to break up into ammonia, NH3, and hydrogen sulfide gas, H2S. And it's going to be 1 and 1. So for every one of the NH3, you're going to get one of the H2S's that are over there. So we can go ahead and we can set this up. We've got NH4HS, that's a solid. That's going to come over here and form NH3 gas and H2S, that is a gas that's there. And we're then going to know that Kp for this is going to be equal to the pressure of the ammonia and the pressure of the H2S, but it's not going to include this guy here because he's a solid. All right. Doesn't mean he's not involved in the equation. It just means that he's not involved in the K equation over here because solids don't get to play in the K equations. All right, fine. So I got an I, got a C, and I got an E. Now, what did it say? It said I put 100 grams of this in there. Not that it really matters because it's a solid, right? And it didn't say anything about these guys being present, 0 and 0. So I'm going to kind of ignore that for right now. It's going to be important later, but for right now, it's not going to be important. Now what's going to happen? What's going to happen is that, just like the last question, these guys are zeros. So this has got to go over to the right because you can't have an equilibrium and be at zeros. So what has to happen here is that this guy has to go down by some amount x. Now we kind of don't care about that for right now, but it does happen. This guy here has to break up into these guys here, so this does go down by some amount x. I don't know what it is, but it goes down, which means that each of these guys have to go up by x because it's a 1 to 1 to 1 ratio that's there. So what's it going to be then? It's going to be that the Kp value, by the way, which is 145, so this is 145 then is going to be equal to x squared, or x is going to be equal to 120, 1.20 atmospheres for the pressure of each of these guys. So that's 1.20 and that's 1.20. All right, well, if that's the case, we can now work our way backwards to figure out what this number here is, because if this is 1.20 atmospheres of those and it's a gas, then I can actually figure out the moles that was, because I know PV is equal to nRT, or N is going to be equal to PV over RT. So this number here, or this number here, quite frankly, is going to be 1.2 atmospheres for my pressure. And they gave me a 2.5 liter container. That's up here. And then R is 0.0821. And then the temperature they told me was 500 Kelvin. So 1.2 at 2.5 divided by 0.0821 divided by 500 gets me a number of moles here of 0.0731 moles. All right, now I'm going to rewrite this just because it's getting pretty messy up here. But basically, guys, here's what happened. I have NH4HS that goes to NH3 plus H2S. And I just figured out that this guy went up by 0.0731 moles, which means that this guy had to go up by 0.0731 moles, which means this guy had to go down by 0.0731 moles. Because again, whatever I lost here, I have to gain equal amounts over there. All right, well, how much does this stuff weigh? It looks like 14 and 4 and another 1 and then a 32 1. It looks like that's 51 1. So this guy here, we multiply him by 51.1 grams per mole times 0.0731 gets us about 3.7 grams that you actually lost. So this guy here is 3.7 3.73 grams that you actually lost. Keep in mind, I started with 100 grams, and then I lost the 3.73 grams. So what does that mean? That means I ended up with about 96.3 grams that were left over. So 96.3 grams that were left over.